Thank you. Thank you, Dootika and Siva, for inviting me. It's a privilege being here, talking to all of you. I know you've just maybe completed 1 year of your college. So we do want people like you in our bank, and this really gives me an opportunity to sell the work that we do. So thanks again for the invitation. Before I get started, let me tell you that, I mean, I'll talk a little bit about large language models. This may be familiar to a lot of you because you might be working with ChatGPT and the cousins and sisters over the last couple of years. But I'll just give you my perspective, and then so this will not be a talk where I get into the modeling or the math behind it, but mainly about how we use artificial intelligence in the bank. So the Commonwealth Bank of Australia is, I mean, all of you are familiar with State Bank of India. So the Commonwealth Bank of Australia, or CBA as we call it, is like SBI in Australia, right? So they do have the biggest customer base. So it's about 16 million, but the caveat is that the total total population of Australia is 26 million, right? Of which 16 million bank with CBA. And 16 million, the Bangalore population is almost there. So this is just to give you the numbers, but yeah, CBA is a bank which is very fast to adapt to the emerging technology. I've also been privileged that I'm working here because there are not many banks. It's a highly regulated industry, right? Because it's financial transactions, you're interacting with customers, you have their money. So most banks are slow to adopt to technology, but CBA is actually one of the few which, when ChatGPT came out in 2023, was quick to adapt, and we have Gen AI in almost all our data science solutions in the bank now. So want to talk a little bit about the AI landscape, right? You're all students of math or statistics. So, you know, interestingly, I had this debate with a colleague. He was like, why do we call something AI, or why do we call it, you know, machine learning? He was like, it's a regression model. I wouldn't call it artificial intelligence. And then there was another colleague who said that, is the function that you're building something which would replace a human being, right? Is the work that you do, will it replace a human being's work? Even if it is one human being, then I would call it artificial intelligence, because the daily work that we do, it doesn't involve some amount of intelligence, right? So that is one definition. So what I want to say here, without belaboring the point, is that a lot of people have different ideas of what artificial intelligence is, what machine learning is, and you may get into these debates later in life as well. But what I told my colleague was that, how do you begin teaching artificial intelligence, right? 101, course 101 would be a regression model. So there is no course that I know of which teaches artificial intelligence that doesn't start with linear regression. So I said, that's your answer. So with linear regression, you predict something. And that is what we do pretty much in data science, right? We are trying to predict something. Now we generate things, but it started with prediction. So this may not be like completely accurate, as in I'm not trying to say that they're all completely subsets of each other. This is just to give you an idea, right? Like artificial intelligence started way back in 1950. There was a brief period where nothing happened, I think. And artificial intelligence, I don't know how many of you have seen 2001: A Space Odyssey. There is this computer called HAL, which takes over the flying of the spacecraft, right? I don't know if you heard. So it's very unsettling to hear. This HAL actually throws out the human, and then the human asks HAL, right? Open the door, HAL. And it refuses to open because it realizes that the human was actually going to shut down the. So it's sort of like if you have autopilot and the pilot decides to take over flying of your aircraft. So that was our first movie introduction to artificial intelligence. And like I said, this is a really old movie, and artificial intelligence has been around since that time. Then we started calling it machine learning because there are repetitive tasks which we do as humans, and you want to let your machine learn how to do those tasks. And again, it was a lot of prediction, so predictive analysis, and we called it machine learning. And then came neural networks, right? Where I have another slide on it, we'll get into it. But again, this was inspired by the human brain, where you have neurons which fire and cause you to create some actions. So neural networks was sort of modeled on how our brain works. So that was another advancement. And this was like you see in the 2010. And then, of course, 2020, generative AI came in. And we'll talk a little more about why it suddenly exploded also a little later. Now, inside generative AI, so I said what your linear regression model does is a prediction. So similarly, generative AI does not, it actually does predict, but what it does is more than that, right? It actually generates. So I'm sure all of you have, I mean, there's no escaping generative AI, right? You open a browser, you have a Gemini icon there. You open your phone now for Google search, it is run by Gemini. I think Llama is there on your WhatsApp messaging service. And of course, ChatGPT, if you downloaded the app, you have it. So there is no escaping generative AI, I think. And some of the examples of large language models I've given you there. There's another variant called a small language model, which makes it a little less heavy. And these were called like Tiny Llama, Phi3, and things like that. And then what I've mentioned in the end is the advances in the last year. So what we call abstracted versions of generative AI as agentic AI, right? So these are, and as the name suggests, it means that this artificial intelligence has agency. So it is autonomous, it can take decisions on its own, it can gather context. So that is what we call agent. So it's not simply something which is which you can think of as a tool calling or a function. So if you, I'm sure in this summer school, you've already learned how to write functions in R. So it's not simply something which calls a function. These agents, as we call them, have some autonomy, right? They can gather context. They can make decisions on whether to take action A or action B. And that's what we call agentic AI. And now if you see, I mean, if you're the people who are working behind the scenes to develop generative AI solutions, a lot of them have adopted the agentic workflow. So, and every big company has solutions for that. So Google has a agentic workflow. OpenAI has come up with that. And then if you've used any of the code development, what do you call it, Roo and Klein, these are all like code helpers. So they actually can take actions, no? So they can look at your code and say, can I modify this for you because this is more efficient, or this is a better way to implement things. So actually it takes actions for you. MCP is Model Context Protocol. This is also something to do with agents. So the minute you have autonomous functions which are doing things like making decisions, you also need to figure out how they interact with each other. So do you have like a supervisory agent which is controlling all the agents that you build? Or is it like a swarm where each one does its own thing and it self-organizes? So that is something, so Model Context Protocol is really new. It came earlier this year. So this is how the AI landscape is evolving. So still pretty much every day, right, there's something new. So it's very difficult to keep track of this, but I guess you have to if you're in the data science world. So I spoke about this already, but if you see how we started, 2020 was when GPT-3 came. And the interesting thing is, GPT, the different versions which came, there was one version which they didn't actually release because they felt like it was dangerous to let something, which was designed to write poems and generate text. When they saw the output which was coming out, the researchers themselves felt like it was too dangerous to let out into the world. So they held back one of the versions. I think that was 2021 or something. And then 2022 was when what you know as ChatGPT came out. And at that time it was only text. Then 2023 saw some audio. By 2024, we have what is called multimodal, which is that it can generate text, image, video. And have any of you heard of the Turing test? Do you know what it is? Yeah, so Turing test was designed to differentiate what was human generated and what was machine generated. And you'll find that increasingly videos which are being generated now, it's very difficult to differentiate what was done by machines and what was actually by people with cameras and massaging it. So while, some people say that we passed the Turing test some time back, I think everything has been debatable. But right now, there are people who are working on these kind of problems, right? Like how to identify text, image, or video, which was AI generated versus not. And maybe if you ask your instructors, they also might be finding it difficult because the answers, if you let people consult, these large language models, the answers you submit also, it will be very difficult to know what you did on your own versus what was generated by ChatGPT. That's what you do, is it? Okay, yeah. Yeah, actually there is someone in the bank who worked on trying to find try to quantify the difference, and it is a very difficult problem. So why is it difficult? I thought I'll go into it a little bit. And why is it called large language models, right? Basically, it's like us humans, whenever we try to, so now I'm speaking, right? Like what I'm talking is maybe, I don't know, a few hours of preparation. I've consumed some information and then I'm trying to process it in a way that I can, make this talk. But in order to get a machine to do that, the questions can come from anywhere. So they actually had to, zip the internet. So you can think of it as a zip file. So they had to actually compress the entire information of the internet, which is like 10 terabytes of text, and then feed it to this model. And then, and these are old numbers, right? My source is Andrei Karpathy, who is one of the leading researchers in this area. So these numbers that he's put here is already a year old. You can multiply it by 10 easily and like still be less than what it takes now. And if you look at what we are doing is like when you're zipping the file, you're actually, I'll talk about what the parameters are, but those are what decides what your model is going to be. And that parameters file is like, that itself, it's just a text file, but it is 140 GB. So like those numbers are for Llama 2 70 billion, which is, yeah, it's already a couple of years old. So this is what I meant by the neural network, which is what we call deep learning, right? Because it keeps getting complicated. So basically, what are we trying to do? What we're trying to do is like a next word prediction, right? So that's what large language models do. And pretty much any model, whether it's a small language model or any language model, it does next word prediction. So, and you would have seen this right from the time, I think if you've used a Word file or your WhatsApp, you would have seen next word prediction way back, right? It's not like it came only in 2020. So what changed? And next word prediction you can do in many ways. So in a neural network, like I said, it's based on our brain. So they kind of, each of those nodes you see there is like a neuron. And then the vertical lines, right, they are all like layers. So it's like one layer passes information on to the next layer and so on. And then finally you get your output. Now, here I want to say cat sat on a, and then I want to predict the next word. Now, the neural network will do it. It will, so you see all the interactions there. That's how each of the neurons will interact with each other. And then finally, it will produce a word, and it will also give you a probability, right? So it says with 97% probability, Matt is the word that would come after you say cat sat on a. So basically, this is what a neural network is. I mean, I'm oversimplifying, but I think that's all you need to know. And this is actually the backbone of a large language model. So imagine that, so all you're doing is the next word prediction, right? Like now, suppose I give you the script of a movie and I tore off the ending. Then what you want your language model to do is to predict that ending. And now it can predict like a paragraph, pages, next word, and so on. But how it does is it takes a set of words, it will predict the next word. Then you give it the correct word, right? Like, so now suppose Matt is the right word, then it ends there. But suppose you give it a different word, like let's say bat. And then you say that that was the right word, but your neural network predicted Matt. So what it does is it will calculate the error from your prediction to the true word and then feed it back. And then you adjust all your parameters or weights again. And this is called back propagation. This is a very important algorithm in neural networks. So basically, once you get your answer, you go back, adjust the weights, come back, and then you keep doing it iteratively till you hit a point where you say, enough, I'm happy with the answer. Now, what a large language model did was do this repetitively, not one time, not 10 times, not even 1 million times, but many billions, hundreds of billions of times, right? And then imagine, like, suppose me as a human or just with a calculator, I could do 100 million additions and subtractions in 1 second. For the scale of a large language model, for it to do this kind of prediction, can you imagine how much time it would take? I mean, and let's say you can already do 1 billion calculations in 1 second, right? You cannot, I mean, there's no way you can do it. So it just, I think it's like more than 1,000 billion or something like that. It's that many iterations you will have to do. And why, I mean, and then, but how are we able to do it, right? Like, so if you run, if you run this like one word at a time, like cat sat on a mat, you do it linearly and then try to predict the next word. If you do it like that, you would spend, I think, upwards of 2,000 years just doing these kind of calculations. So what changed was in 2017, the Google researchers came out with a paper which introduced something called a transformer. So what the transformer did was actually do these calculations in parallel, right? It no longer took in one word at a time, but it would take all the words and it will also try to find the association between them. So it was called attention. So it not only, so for example, this is a very common example which people use. So suppose you say, I had a picnic on a river bank, right? And then another sentence could be that I withdrew some amount of dollars from a bank. Now, both of these sentences have bank, right? But how does your language model know which bank you're referring to? Are you referring to a river bank, or are you referring to a bank like Commonwealth Bank of Australia? So that's where this very important paper from Google came in, because it was able to take in the input parallelly. It was able to form associations with words, right? Like, so bank, it could associate with the river, and in the other sentence, it could associate with money. And this happened only because we were taking in everything at one time. And as you can imagine, though this was complicated, it also, because of the parallelization, we are able to get answers very quickly now. And if that hadn't happened, this field wouldn't have exploded either. So this is what I tried to explain. I don't have slides for that. There's a lot of information. I don't know how many of you do. Are you familiar with 3 blue, 1 brown? Yeah, you should go and listen to the video that he has on LLMs. It's really nice, right? I mean, I'm a big fan. In just like 5 minutes or 10 minutes, he breaks down like very complex concepts into understanding. So I would highly recommend that you go and watch it. But basically what I want to say is, like you would be aware, if you're following all of these models, the names, right? They also say, so like if you see 70B, Llama 70B, that is 70 billion parameters. This is like 100 billion parameters. So what I said about attention was that it gave you the context to each word, right? It was sort of encoding it. What you see here is like there is multi-head attention, right? And this is what happened under the hood. So you have inputs, you have some positional encoding, then you have these different layers, and then finally, so the backbone is a neural net, but because of the attention and the various layers that got defined, we are able to do these many complex calculations in under a second, or a few milliseconds actually. The problem with this kind of scale, right, like so many billions of interactions, is that no one really knows how it works, right? I mean, if anyone says that, even the people who are building these models at OpenAI or Anthropic, no one really knows what's going on, right? All they know is if they tweak it in some way, the answer comes out in this. So you can focus on like one layer, like which is close to the output or something like that. But because there are so many layers and so many millions of interactions, no one really knows what happens when you tweak it. What I told you about training, right? Like where we are compressing the internet and giving it, that your story doesn't end there actually. So you can give all this instruction, you can train your model, you can compare how it is to the output, do this back propagation. And then what it's called is, what they do repeatedly is this feed forward. Like each layer will get one bunch of weights, it will feed to the next layer. So it's feed forward, attention, and it goes on like that for, I don't know, many times. But that is actually called pre-training. It's not actually the training of the model. So that pre-training fixes the parameters for your model, but from there to a chatbot, they still needed to take one more step. And that step was called reinforcement learning with human feedback. You might have heard about that. That is also a big field in data science now. It's called RLHF. So what they did was have a bunch of humans evaluate the output, right? So they did this feed forward, attention, back propagation, everything, and then they finally fixed this 70 billion parameters. But then when they gave a question to this model and they got an answer, they actually had human say like, oh, this answer is rubbish. So they had to, or this answer is very good. So they had humans sit and evaluate a bunch of questions. And then based on that, they changed the parameters again. And then we finally got what you know as ChatGPT now. And this is ongoing, like the models are becoming better. So it's what we call context length, right? Like, so before you could only send in a limited amount of text to your model. Now you can upload documents, you can upload a video. So what happened was, as we get better at this, the context length changes. The model is becoming cheaper to use. There is reasoning. So a whole lot of improvements as we speak. So that is about what I wanted to tell you about large language models. And then, yeah, we'll come to how we are using it in CBA. But before that, how are people using GenAI in 2025, right? Before that, of course, we know it was more like a fun thing. You gave it questions and you looked at how it reacted. Maybe you wanted it to do your homework or something. But broadly, these 6 areas is how people are using GenAI, and this is from filtered.com. This is a survey company which runs and gets these kind of information for us. So content creation and editing, that was the biggest thing in 2024. From 23%, it dropped to 18% this year. Technical assistance and troubleshooting, again, it was pretty high, came down by 5%, 6% this year. Professional and personal support went up by a large amount. Learning and education largely remains the same. Creativity, recreation, research analysis is all a little bit like 10%, but roughly remains the same. So now I want to come to how we use AI at CBA, right? So largely, like I said, we have taken to GenAI very well. And the last 2 years, we've been using GenAI in a lot of our solutions, and that's what I want to talk about today. We are also looking at making it building these sort of agentic frameworks where we allow the AI itself to make decisions. And yeah, you might have heard of like these HR systems. Like, I don't know, I mean, this may not be. So it's something like, so if I'm an employee in a company and I want to apply for leave, right? All I need to do is, if I have a chatbot, I say that, oh, I'm looking to take a vacation sometime in July. And then the assistant itself goes, looks at your leave balance, decides if July is a good month, or it will make suggestions for a better month. And then if you agree, it will go to the portal where you have to apply for leave, submit the request, and things like that. So that is what we are looking to, where systems will progress, right? And I think a lot of it, where people see a need, they actually start using it. So in software development, there are these software development life cycles, right? Like, where we know there are definite outcomes at each level, where you know that you have to build the design first. Then once you have the design, you go and build all the blocks. And then once you have the software developed, you have a testing life cycle. Then there is a feedback loop. So all of these are sort of defined. And so then you can use agents to do each of these tasks and take actions on your behalf. I mean, we are still building our agentic solutions, but what I'll talk about is how we've used generative AI. And I mean, all of the older versions that you saw, machine learning, so what we call traditional ML now. So what we did was, I'll talk about each of these cases in detail, but this is just to give you a brief overview. The first one was how we helped our customers take control of their finances and bill payments, right? So if you have, so I haven't downloaded, I have an account at SBI, I haven't downloaded the app. But if you're a customer of CBA in Australia, your app would tell you something like this, right? So, and we called that model Bill Sense, where it sort of does a customer profiling. It looks, so suppose you're someone who's applied for a home loan, right? Then it will tell you that your payment is upcoming, or if you have like an education loan, and it knows, So we have access to all the data. So we sort of process like this is how you make your money, this is how you spend your money. And so we predict what will be your expenses in the upcoming days. And so like you see, it says next 30 days you have your TV subscription, your home loan and things like that. And this is, I mean, you don't need Gen AI for this. This was a very traditional predictive modeling. This was an interesting use case. Again, this is also pretty straightforward, I would say. So Australia has a lot of natural disasters which occur, right? There are bushfires, there are cyclones, earthquakes, and people do live in remote areas because it's a large country. So getting access to them actually is a pretty big challenge. So what we did is actually get this data from, so the announcement about these natural disasters comes from external data, right? Like, so you actually buy it. You say that we want to know this information about when is there the probability of a bushfire or a cyclone or something like that. We buy that data. And then that is matched to the internal data. Like we find customers who are in the affected areas. And then again, we send them these personal advisory. So, you know, right, like so if there was a flood in, let's say, in my hometown, Chennai, right? Imagine if your bank app tells you that, you know, there is a flood or there is a cyclone warning in the next 2 days, so take care or evacuate. And this is the advisory from the government. So it's like that. And this was done because of data science, right? So it's a matching of the external data signals with our customer base and ensuring that they get the message. Next is, this is a personalization of customer interaction. So what is CE is a customer engagement engine, right? And this was actually an award-winning solution. There was a Harvard case study, which I believe anyone can access. So they, this customer engagement engine was actually published there. And what it does is, so why do you need that, right? So these are called like next best conversations. So they are like campaigns which companies run. So if you're a retail company or a bank, then you have to reach out to customers with their offerings, right? And CBA has like 2,000 models, like where, or 2,000 next best conversations. So how do you find the ones? So if I bombard you with 2,000 models, it becomes overwhelming, right? So what we did is actually a sort of ranking. So and you personalize it for each person, right? Like, so if you're a student, it would give you all the bank offerings which help a student manage their finances better. If you're a homeowner, then is there something you can do to make your payments on target? So that was the data science use case here. And if you can see, so this example actually says, so the pocket money lessons are life lessons. So these are messaging which the bank has come up with, which will be sent to the Combank app. So, and this involved a lot of data crunching, I would say. There was also the customer loyalty program. So you know of these loyalty points, right? Like if you're on Book My Show or anything, right? Like Big Basket or Swiggy, you accumulate loyalty points. So this yellow also uses some data science where it targets messages like with respect to like telecom, entertainment or things like that. And again, it gives you information on you got like 10 loyalty points because of something you did. And so it encourages behavior which helps you be more financially sound. So this is something which CB has done very well, and I'm currently working in the cybersecurity domain, so this is also close to my heart. But do you know that worldwide there was actually a $1 trillion loss in 2024? So, and I mean, this is not only Australia, right? This is globally. So people lose that much money to scams. And last year's loss to scams was like $1 trillion. So this is a big problem which is faced by most banks. Somehow they have to cut down on the fraud and scams which happen. So CBA actually achieved like a 70% reduction in scams just through AI-based alerts. And again, how do we use AI here? What you see below is like more prevention, but what I want to talk about first is detection itself, right? So there are various cases. One way is, yeah, so how do you detect, right? Like, so you can think of it like yourself. Like, so suppose your average transaction per day is something like, I don't know, 1,000 rupees or something like that, right? And suddenly you see a transaction for like 30,000 or something. So that is something which should trigger an alert, right? So that is a simple way, like, I mean, you don't need an AI model for that, but any abnormal behavior. So like an anomaly detection, that is one way that people actually detect fraud. It actually happens. Just last month or so, I was in Australia. And when I used my personal credit card, they blocked it because they saw a dollar amount and they said that this is a suspicious transaction, so they blocked it. And then we had to call the helpline and then get it, say that it was me, don't block it and so on. So what CBA did differently is whenever there is like an alert which tells you that they've detected a suspicious activity, what they do is they immediately ask you to confirm. So it comes on your Combank app and say, was this done by you? And if you say yes, of course, there's nothing to do. And the thing is, usually they say don't respond, right? And you'd have seen this with email and all that. What they want is for you to actually confirm that it was you. If it is not you, your card is immediately cancelled and a new digital card is given then and there. And this happens in like real time as you're transacting. And this has really improved the customer engagement engine. And again, a lot of data science has gone behind it. There are various ways we can do this, right? Like, so just like you have a blacklist, so you know some fraudsters, some people or institutions who commit fraud and who run scams, you can have like a whitelist, right? Like, so each person, you sort of have a network of people that you regularly transact with. And so they are like your whitelist or your circle of friends, right? So these are some ways where you can say that this transaction was okay, though the amount seems to be anomalous. So some models like that. The ones below are, they're not detection, they're more prevention. And among them, name check, CBA was one of the first ones to do it. So when you use UPI, right? Usually when you pay money by the UPI ID or the number, you check the name, right? Like whoever you're paying to. Let's say you're paying your cab driver or something like that. Your name comes and then you make that check, right? Like you say, is this the person? Am I transferring money to the right person? What CBA did is actually have the name check done ourselves. So we do the verification for you that this is a verified business, this is a verified individual, and that the spelling and everything is fine. So this actually saved a lot of money. Yeah, there are customer check, caller check is all very similar. Yeah.
That should, like, in practicality, it will make a difference. But do you keep like hospitals and big government institutions in the whitelist automatically?
Yeah, that's a good question. So her question is, do we keep like hospitals or known big entities in the whitelist? I don't know. I mean, I know we built this circle of friends, but I don't know if they have these kind of institutions. Some which go to the whitelist are like recurrent payments, right? Like, so if you have like a subscription to an online service, those go into the whitelist. So the whitelist is maintained per customer. Yeah.
So the paying to a hospital, obvious that hospital is probably not. So you don't need to trouble the customer to give a ticket.
Correct. The problem is these fraudsters are also becoming more and more clever. So, there is actually one industry which think of ways in which to scam. So they can also have a front, like they are a hospital. So it actually, you have to do it both ways, I think. Like you do need that verification, especially because hospitals may also need like large amounts of money transferred immediately. But I would say CBA is handling it. I mean, all of these would have been taken care of. I'm not aware, but yeah, it should be there. Yeah. And intelligent friction is something, so this, I mean, just a name that we call. So friction is like for them to prevent the transaction, just like I said, when I went abroad and my transaction was declined, right? So when and you can get all this information from the customer base, right? You have a lot of information just because you have the customers. So intelligent friction is like to stop you from, or stop some transactions from happening which have some bad signals. Oh, this is a very nice case. I mean, this was done, I think, in 2023. So this was something which CBA saw, right? Like where, so whenever you transfer money, you have that small window to give a description, right? In CBA, it was 180 characters. And what someone noticed was that people was using those 180 characters to actually abuse, right? So they would transfer like $1 20 times in a day, but use those messages to, and this was abuse of the elderly. It was like some stalking, there was some profanity. So when this came to people's attention, they started detecting cases where the amount transferred was small, but the messages were actually objectionable. And CBA came up with this. So if you see, like there is an error which comes up if they see it is profanity or there is some objectionable words being used, then it comes up with that error message saying your message is actually offensive. Can you reword? And so it would prevent this message from going through. This is a machine learning based solution because what you had to do was detect. So you had to do a sort of text classification, right? Like say that this text was profanity or not, or it had some objectionable language. And this was before LLMs. So what it used was what is called a BERT. I don't know if you know, it's a bidirectional encoder representation of transformer. So it does some context learning, but it does a pretty good job of classifying the text as blasphemy or not. And with that, we were able to stop. So those kind of transactions were blocked. And this model, because we felt that it was something which was built for social good, we made it available. Like there's a company called H2O.ai, which is a data science company. So in partnership with them, we built this code, and you can see that it's on GitHub. You can even access it. Many banks in Australia have taken it. So this is something which you can add to your app, which prevents this kind of abuse from happening. And it was mostly targeted at like, elderly people or people going through breakups and things like that. So they did see a lot of transactions like this. Next is, this is more in keeping with the times. So this was about last year, where you actually interpret what the user is looking for and provide contextually relevant responses. Pretty much, I think we are also the first bank to use Gen AI in the chatbot, right? Like even now, most of the chatbots you see, they have the responses already tabulated. So it will be one of 6 options that you can use. So CBA was one of the first to use Gen AI in their chatbots. And this Combiz actually says, it's your AI assistant, it can help you, like, so what is a fast payment? You can ask it, how do I create a fast payment? How do I add an account authority? Anything. So it uses our information to give an answer. There are many applications like that. I mean, even inside CBA, we have this Teams chat, and so in-house we built like an assistant which will help me with my IT queries or any difficulties that I face with getting accesses and things like that. So CBA is really good with that. So this is a video which tells you how we use Gen AI powered messaging. Don't know if you can see. Is it running? I think this may be because it needs the internet or something. I don't know. Yeah, but I can just skip through. So it asks you if you need help. Yeah, so most of what I talked about are like for retail customers, right? Like, so customers like us. But CBA also has institutions who are customers. They have businesses who are customers. So a lot of data science solutions happen across all of them. I think that is the end of my talk. So we can have a discussion now. I think. Any questions? We can talk more about things like what you asked me, like hospitals. Yeah. Yes, yes, that's a very good question. I think we do have a lot of work going on there. A lot of what you're seeing, the Gen AI powered messaging does look at, so there are disputes, complaints which are being handled. So these are channels where a customer can actually lodge complaints about some service which they receive, which they're unhappy with, or there was some glitch or something like that. There is what is called, there are some surveys which also happen at physical banks as well and online. And we do use Gen AI actually to do that. So this sort of survey, bucketing it into different sentiments, right? Like, so there could be like 10 different kind of sentiments which we want to analyze from these surveys. That is also done using data science. But yeah, the regular complaint resolution, dispute resolution also has a lot of AI which is being used. So where we started with was actually, so the bank manager will have to, for each case which is resolved, the bank manager has to send a letter. And the first draft of the letter was done using Gen AI. So I think it reduced the time by, yeah, maybe 20 times or something that it takes, that it used to take the bank to respond to what we do currently. Yeah. Correct. Yeah. 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 No, a very good question. I'm glad you asked that. So CBA prides itself on being, responsible AI, and that is because, I mean, as you know, even these large language models, when they first came out, they would hallucinate a lot. And you could even ask it something like, how do I build a bomb? This was in 2022 and 2023. But you can try it now and you'll see that it says I'm not allowed to answer. So the guardrails have actually gotten better by the models themselves, right? But even as a bank, CBA is very, very particular about this. We have something called a responsible AI toolkit, which is like we've had a bunch of data scientists working on this, and they actually ensure that these guardrails are in place before any model is exposed to the customer, or even even if the customer is internal, like within the bank, they ensure that we pass all these checks and balances. And this is not something new, right? Like this didn't come only because generative AI has the license to generate whatever it wants. So even in our traditional machine learning, we had what is called a model monitoring. So because we work in these kind of probabilities, right? Like we say, this model is 90% accurate, and then we start using it. But what happens is once the model is live, right? Like there is one part where we are working with known data, and then it works with completely new data. So we actually have a model monitoring framework where it continuously models the performance of the model. And then the minute some threshold is exceeded, that model is taken out. So these kind of safeguards were already in place. And for generative AI, like you're saying, we are continuously improving them, but we do have, yeah, a responsible AI toolkit. Yeah.
Do we have other questions? If not, then let's thank the speaker again.
Thank you.